Right, so a cord is wrapped around the outer surface of the 8-kilogram disc, then a force of something newtons. All right, so it's a formula depending on the angle in radians that apply to the cord. Determine the disk's angular acceleration when it has turned 5 revolutions. The disk has an initial angular velocity of omega 0 equals 1 second. All right, so the first thing to do is to realize, I mean, it's pretty easy. You start with the moment of inertia, right? For a disk like this, it's going to be 1/2 mass r squared, right? Which is 1/2, mass being 8 kilograms, the radius being 300 millimeters, so that's 0.3 meters squared, right? Which gives us total value of 0.36 kilograms meter squared, right? And then, of course, we want to do, right, so like if we were to do a quick free body diagram, right? I'm gonna go here, for example. And you have your circle that's pinned at O. And then you have some force here that you don't really, I mean, you know it, right? Which is going to be 1/4. All right, so this force here in red is going to be 1/4 theta squared. All right. And so you know that the sum of moment around O, and so let's call this O here, is going to be force times 0.3 meters, right, equals I alpha. Therefore, this is 1/4 theta squared times 0.3 equals 0.36 alpha. So alpha is just going to be 5 theta squared 0.3 divided by 0.36, which has an answer of 0.02083 theta squared, right? And since we want the angular velocity, right, we will need to integrate. We will need to integrate, right, from, so basically we know that the velocity, like the omega, is going to depend on alpha, right? Just going to be alpha times, yeah, so basically we're going to want to integrate a variant of these two. So it would be omega d theta, right? So we want to integrate this, so it's going to be from omega 0 to current omega, and alpha, and it would be theta 0 to current theta, right, which is 5 times 2 pi, because we have been doing 5 circles. And I have the equation 0.2083 theta squared d theta. And move the next problem a bit down. Here we go. And then we do the math here. Basically, this becomes 1/2 omega power of 2, right? From omega, and omega 0 was 1, going to be equal to 1 over 3 times 0.2083, oops, 2083 theta squared, to the 3, sorry, 10 pi 0, all right, which gives us minus 1 equals, and so 3 becomes 0.06944, all right, 10 pi to the 3 minus 0. So new omega is just basically going to be 0.6944 and pi to the 3 times 2 divided by, sorry, not divided, plus 1 square rooted, which is going to be 65.63 radians per second. And this is our final solution.